Hello friends, welcome to Learner's Planet. Friends, in this session I am going to take some area related problems where we have to find out the ratio between two given areas. So let's take the problem one by one. Friends, to solve the problem based on area, when we have to find out the ratio between two areas, um, you need to have the basic knowledge of geometry and the very basic knowledge of trigonometry both as well, right? The basic knowledge of trigonometry, what I mean over here, must be knowing the values of sine theta, cos theta, tan theta, when theta is 30, 60, 45, 90. I just write it for you. Sine 30, it's half. Sine 45, 1 by root 2, sine 60, root 3 by 2, and sine 90, 1, right? Cos 30, root 3 by 2, cos 60, 1 by 2, cos 45, 1 by root 2, and cos 90 is 0, and cos 0 is 1, right? And tan theta can be obtained by sin theta by cos theta, right? Sin 30 by cos 30 is tan 30, so tan 30 will be 1 by root 3. Okay. Similarly, sin 45 by cos 45 is tan 45, so tan 45 is 1. Sin 60 by cos 60 is tan 60, so tan 60 is root 3. And sin 90 by cos 90 is tan 90, so tan 90 is not defined, 1 by 0, right? So this much knowledge you must be having. Apart from that, you must be knowing sine formula, cosine formula, and the very basic knowledge of geometry you must be having. So let's do some of the problems. Friends, in such problems, generally there is no requirement of paperwork. Just simple logic of geometry are used. Here we are given a square that is ABCD, and P and Q are midpoints of AD and BC, and this point X is taken over the side CD. The ratio of dx is to xc, that means this is to this is 3 is to 2. Now what we have to do? We have to find out the ratio of this triangle XPQ and the square ABCD. Now friends, no need to go for any sort of detailed paperwork. Directly you can say this triangle XPQ will be 1/4 of this square ABCD. Now how it will be 1/4? Just listen to me carefully. See, suppose I draw a line over here, this line. Now what will be the area of triangle PDQ? See, this PQ is this joining the midpoints of this side AD and BC over here. That means area of PDCQ is half than that of ABCD, and this rectangle PQCD is further divided into two equal parts, right? That is triangle PDA, PDQ and QCD, right? That means this triangle and this triangle, both of them will be having the equal area, right? Now the third triangle, that is PXQ. Now you can very well see that all the both the triangles, like this triangle, that is PDQ and PXQ, both of them are having the same base, that is PQ, right? And their altitude is also same. So obviously area of PDQ will be equal to area of PXQ. Doesn't matter the ratio dx is to xc is 3 is to 2, whether 1 is to 1 or whatever, any other data, right? The area will remain same if they are having the same base and same altitude. So base is same, that we can very well see, and altitude will also be same. Its altitude will be like this, and its altitude is on the same length. Okay, so if PDQ is having 1/4 of area, PXQ will also be having 1/4 of the area. So what will be the ratio? That is 1/4. Okay, so just simple conceptual problem. No paperwork is required at all. I hope you are clear. So we have used this logic over here. Triangles between the same base and between the same parallels are equal in area, right? So just keep this logic in your mind and note it down. Let's take the next one. Now we have this problem. Here ABCD is a rectangle. Here Q is the midpoint. Here P is the midpoint. we have to find out area of triangle PQB with respect to this rectangle ABCD. Right? Once again, a simple problem. See what you can do. You can assume the length and breadth anything. Suppose it is 2L and it is 2B. Right? So area of rectangle is what? 4LB. Now see this triangle. Area of this triangle is what? Since this length is 2B, this length is B, this length is B. So area of this triangle will be what? Half of B into 2L. So what I can say? L into B. I just write it over here. Similarly, area of this triangle is half of L and half of B, right? So half of, I'm sorry, L into B and by half, right? This length into this length and half of that, okay? So it's LB by 2. So in all it is 3 by 2 LB. 1 is this and then half is this. Then this is what? This length is L and this length is 2B. So further it is half L into 2B. So it's L into B. So it's precisely 5 by 2 LB, right? So from the entire area, if we deduct 5 by 2 LB, we will be getting the area of this triangle PQB. So the combined area of these three triangles is 2.5 LB and the total area is 4 LB. So the remaining area of triangle PQB is 1.5 LB. So that's 3 by 2. So it's 3 by 8. Okay, I hope you are clear. Now you can even use the percentage method over here. For that you need to draw lines like this, right? After that just calculate the area. So this particular triangle, this particular portion is of 1/4 of the rectangle and this triangle will be further half of that, right? So in all it is half of 1/4, that means you can say it's 1 by 8, right? Now if you compare this and this length is this length from this point to this point is half of this, right? Altitude is same but base is half, that means area of this portion is 1 by 16, right? Area of this is 1 by 16. Similarly, area of this is also 1 by 16. Now I have to find out the area from this point to this point to this point, right? If I take the complete portion, the area will be 1/4 because this rectangle, this is half of the entire rectangle, and this triangle, this from this point and this point, it's further half of that, that means 25%. From 1 by 4 I need to deduct this 1 by 16. So what I am doing, 1 by 8 plus 1 by 16 plus 1 by 4 minus 1 by 16. 1 by 4 is this complete and from that I am deducting this. Okay, so it's 1 by 8 plus 2 by 8, that's 3 by 8, right? You can go either way. The same problem can be considered even for a square. The same way you can go. I'll just show you it once again. So here also all the sides are same, so you can go by that length and breadth method, or you can even go by the percentage method. Now this is further 1 by 4 and half of that is 1 by 8. This is 1 by 16 because it is half of that. We'll deduct this 1 by 16. And area of this complete, suppose it is O. So OQBA, the area will be half than that of the entire square, and half of that will be the area of OAQ, triangle OAQ, right? So from that half we need to deduct this 1 by 16. So precisely it is 1 by 8 plus 1 by 16 minus this 1 by 16 and plus the entire area OAQ. Okay, so it's 1 by 8 plus 2 by 8, 3 by 8. The answer will remain same as in the previous case. Okay, or alternatively what you can do, you can assume the lengths to be 2L, and in this case all the lengths are same, so you can assume the length to be 2L, and then you can deduct the area which is not at all required from the entire square. That method is also very easy. You can go by either way. Similarly, in this case, we are given that PQRS is a parallelogram. Here Y is the point on side QR and here X is the point on side SP. Now this Y it's the ratio of QY is to YR is 1 is to 4. Now we have two questions we have. We have to find out the area of XYZA. That means area of this quadrilateral with respect to the entire parallelogram. And apart from that, then ZAY, that is this triangle with respect to the entire parallelogram. Now once again, very simple thing. Now here in this case we'll be using this logic. The area of a triangle is half of the area of the parallelogram on the same base and between the same parallels. That means area of triangle XZA will be half than that of PSZA. I matched ZA, so we further got a parallelogram APSZ, right? So area of APSZ is half than that of the entire parallelogram, right? And after further XZA is further half. So precisely it is 1 by 4, and the same logic is applied over here. It's still 1 by 4, right? So 1 by 4 plus 1 by 4, that's 2 by 4. That means it is half. That is area of XYZA is half than that of PQRS. So this ratio is what? Half, right? Similarly, ZAY, that is 1/4 of the entire parallelogram. So it's 1/4. Okay, very simply you can do the problem if you know this logic. The area of triangle is half of the area of the parallelogram on the same base and between the same parallel. Does not matter where this X is located. Maybe X is anywhere on this line. The area will remain same. Similarly, Y is anywhere on this line. Whether it maintains the ratio of 1 is to 4 or any other ratio doesn't matter. The base should be same and the altitude, that means they should be between the same parallels. Okay, I hope you are clear. Now we have regular hexagon over here. We match the three vertices ACE and we have to find out the ratio of ACE to the entire hexagon. Okay, so what you can do is I just match up I've drawn the six or converted this hexagon into 6 parts. Okay, that you can see this triangle and same 6 triangles are there, right? Now the entire hexagon, regular hexagon, can be converted into 6 equilateral triangles, right? That you can very well see. Now if the each and every portion is considered to be say X, right, then this entire hexagon is the combination of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, right? So 12 equal parts. Out of that 1, 2, 3, 4, 5, 6. 6 are coming in this triangle AEC. That means portion out of 12 portions, 6 portions are there in this triangle. That means the ratio is 1/2. Okay. Here we are having a regular hexagon ABCDEF. By joining the midpoints of the adjacent sides, we have drawn a rectangle over here, that is PQRS. Now we have to find out the ratio of area PQRS to the entire hexagon. That means this PQRS is with what part of the entire hexagon, right? Now once again we'll be drawing some lines and we'll be converting this hexagon into 6 regular equilateral triangles. So now it is, I assume the side of this hexagon to be 2A. Then according to the midpoint theorem, this must be A because this is the midpoint of this side, this is the midpoint of this side, and this line is parallel to this. That means according to midpoint theorem, this portion from here to here, it must be A. Now we can see the symmetry. Here if it is A, even it will be A, even it will be A. The total length of this rectangle will be 3A. Right, now we are interested in the width of this rectangle. Now this angle must be 60 degree. Okay, and this length, the entire length is 2A, so this length must be A and we want this length. So relation of this and this is given by sine theta, that is perpendicular by hypotenuse. So x by A is sine 60 degree and sine 60 degree is what? √3/2. So x by a is root 3 by 2, right? So this length is root 3 by 2a. That means the complete length will be 2 times root 3 by a. So we can say root 3. So this length is root 3a and this length is 3a. So this is the area of this rectangle. And area of ABCDEF, that is hexagon, that is a combination of 6 equilateral triangles. So 6 into root 3 by 4 a square, right? Root 3 by 4 a square is the, I'm sorry, here it will be, side is 2a, so it is 4a square, right? It's precisely root 3 by 4 side square. So side is 2a, so 4a square, and 6 equilateral triangles are there like this. Okay. So precisely it is 4 by 2, or we can say, sorry, this and this is also cancelled, so it's 1 by 2. Okay. Now friends, let's see this problem. Here ABC is an equilateral triangle that is given. This line is parallel to this line. This is the midpoint. And if we see carefully, we have to find out the area of triangle PBR with respect to triangle ABC. Now see this is one triangle APR, this is one triangle RQS, and this parallelogram PBSR is the combination of two triangles, two such triangles. So precisely this is 1/4 part, this is 1/4 part, and this is half of the this entire triangle ABC. Okay, if I draw this line, you can very well see it. Okay, that means area of PQBS is half of the triangle ABC. Okay. Now, keeping PQ as base, if we draw any triangle on this base, the area of that triangle will be half of this parallelogram, right? Just listen to me carefully. Keeping the base same as PQ, if we draw a triangle, suppose if I talk about this triangle, okay, this triangle, the area of this triangle will obviously be half than that of PBSQ. But now what is happening over here? The base is also halved, right? This base is also halved. So in all, the area of PBR will be half of parallelogram. Okay, so half of parallelogram. That means, and parallelogram is actually further half of triangle ABC. So half of triangle ABC will be the area of PBR. So that is 1 by 8. Similarly, if you have to find out the area of RBS, triangle RBS, then between the same parallels PQ and BS, the area of this triangle is half that of parallelogram. Now parallelogram is half, and half of this, that is 1 by 4. Okay, with respect to triangle ABC. So I hope you are clear with both the areas. Or else what you can do is you can draw a line like this. I just draw it for you. That joins the midpoint of BS, right? Now you can see 1, 2, 3, 4. All the 4 are equal to each other because the base is same, right? So area of PRB will be 1/4 of PQBS, and PQBS is what? It's half of the triangle. So 1/4 of half of the triangle, that is 1/8. So by drawing this line also you can find out the respective area. Similarly for RBS, 1, 2, 3, 4, and it is containing 2 part. So 2 part, that means the area of RBS is half that of parallelogram, and parallelogram is further half of ABC. That means RBS is half of ABC, that is 1/4 of ABC. Okay, this way also you can go. Now this problem, here triangle ABD is given. We have to find out the area of ACE with respect to the entire triangle ABD. Okay. Now BC is CD, that means AC is median. Now AC is median. Now friends, median actually divides a triangle into two triangles of equal area, right? That means ABC, area of ABC is equal to area of ACD, right? Area of ABC is equal to area of ACD. Further we can see this length is equal to this length. That means CE is median. That means CE will also divide this triangle ACD into two triangles of equal area. That means CED is equal to CEA, right? So CEA will be half of ACD, isn't it? So precisely it will be 1/4 of the entire triangle. So this ratio is what? 1/4. Okay? So this is solved. Now suppose you have to find out PEC. Further, this is the median that will further distribute this triangle into two triangles of equal area. So 1/2 of 1/4. This triangle will be half. This triangle will be half. So half of 1/4, that is 1/8 with respect to the entire triangle. But here we are 1/8 with respect to triangle ABD. But we are asked about triangle ABC, so that will be 1/4, because ABC is actually half and ACD is remaining half. So with respect to ABC, it will be 1/4 only. Okay, be careful about it. This is ABC and this is ABD. ABD is the entire triangle. ABC is just half of the triangle. I hope you are clear. Now this one, here we have to find out area of PQED with respect to the entire regular hexagon. Now friends, I assume the length of this side of hexagon is suppose A. So this must be A, this angle is 60 degree. So this must be √3/2 of A. Okay, so area of this will be what? A into √3/2 of A. A into √3/2 of A. Right? This is the area of PQED divided by 6 equilateral triangles. So 6 into √3/4 into A square. Okay, so 4/12, the ratio is 1/3. Just matter of 30 to 40 seconds. So friends, all you need is just a basic knowledge of trigonometry and a very basic knowledge of geometry. So by that you just can solve all these sort of problems based on a ratio of areas. Now friends, in this case we have to find out the area of this triangle. Suppose it is A, B, C with respect to this regular hexagon. Now further, once again what I will be doing is I'll just complete the triangles over here. Now this upper portion is actually half of the hexagon, right? After that suppose this is, I take this as, after that this is one triangle, this is the second triangle, and this is the third triangle, right? So this is suppose two part, then this will be one part, one part, one part, and one part, right? This is complete two part, this is also complete two part. So in this triangle we can say 2, 3 and 4 parts we are getting. Okay, so 4 part out of total 12 part, because an equilateral triangle is of 2 parts, so there will be 6 equilateral triangles, each will be having 2 parts, so in all 12 parts. Out of that we are having 4 parts in this triangle, so the ratio is 1/3. Okay, I hope you are clear. In this case we have to find out the area of triangle ODF with respect to this hexagon, right? Further I'll be drawing the lines over here. So in all, suppose there are 12 parts, so this is 6 part, the above is 6, out of that this is 2, this is 1, 1, 1 and 1, right? So we have to find out ODF, that is 2 part out of total 12, so that's 1/6. Okay, as simple as that. Now Similarly, we have this problem. Here ABCD is a parallelogram, and we have to find out the area of triangle ODA with respect to ABCD parallelogram, right? Now you must be knowing that apart from that, PD is equal to DC is given. That means base of this parallelogram and this triangle is same. That means area of this triangle APD must be half of ABCD, because they are having this length of the base as same and they are between the same parallels. And you can very well see it by this. Okay, so this triangle and this triangle, all of them are having the same area. Okay, after that, see, M is the midpoint. That means AM is the median, right? Now median distributes the triangle between a triangle between two triangles of equal area. I further draw a line for you. This. Okay. Now we are interested in ODA. That is this part, right? Now this is actually 1/3 of the entire this triangle. 1/3. Getting my point? 1/3 of ADP. And ADP is half of ABCD, right? So it is half of ABCD, right? So with respect to ABCD, it is 1/6. Not much paperwork is required, just need some of the concepts of geometry. That's it. Okay, must be knowing that this is a centroid, and centroid distributes the triangle, this median into ratio 2:1 from the vertex. Okay, so these three will be triangle congruent to each other. I hope you are clear. Friends, in the next session we'll be taking some problems based on polygon in polygon in polygon, right? So please revise this session before you come for the next session. Bye bye.